So here's the final example in this section, example 9, and this is on chapter 9.4, unusual approach. Let's read through it. Particle P is moving on the x-axis with constant deceleration 2.5. At time t equals 0, the particle passes through the origin, moving in the positive direction of x with a speed of 15 meters per second. So let's just draw that out so it's nice and easy to see. So we take the origin. It passes through, moving in a positive direction with 15 meters per second. So we'll define to the right as our positive. So initially v is 15 meters per second. The deceleration, so double arrowhead for acceleration, 2.5 meters per second squared, and that's negative because it's decelerating. And that's all happening at t equals 0. It's moving in a positive direction. Find the time between the instant when P first passes through and the instant when it returns. So it is going to do something out like that. So it's going to go out and come back, and we want the time at which it comes back. So very similar to something we did on the last example. We've noticed it's constant deceleration, so we can say constant acceleration. A is negative 2.5 meters per second squared. Take care with the signs. And we want the time. So that's what we're trying to find. So call that capital T. We're told U equals 15. And we don't know V when it returns. What we do know is that S equals 0. It's back to its starting position. So we want the equation. Well, you should be able to tell me without V. What is it? Hopefully you've remembered. State S equals ut plus a half at squared. Now take care substituting in. So S is 0. U is 15t plus negative, and I'm going to write it as 5 over 2, because it's easier to work with the fractions than the decimals, t squared. So we've now got 15t minus 5 over 4t squared. Let's get it on one line. 60t minus 5t squared. Normally we would make it positive, but it's a very easy quadratic to factorise, so we're going to take the 5t out, leaving 12 minus t. Therefore, S equals 0 when t equals 0. Well, that's reassuring because it was there at the start, and t equals 12 is when it's returned to its starting position. Okay, the total distance travelled by P during this time. So, what we need to do is to find out how far this point is here. Here it turns round. So how far that is away, and then double it. Now there's lots of ways of approaching this. Depending on how much you understand of the motion. So there's a number of things we know at this point. We know at this point V is equal to 0. It's not moving away and it's not moving back. At that point the velocity is 0. We also happen to know, if we're intuitive, that because the acceleration is constant, the time to this point is half the time it takes to get from O and to O. So I happen to know at this point, by understanding the question, that t is going to be equal to 6. what else do we want to know? We want to know half the distance, so we're looking for S, and we know that A was equal to minus 2.5, and we also know that U was equal to 15. So we know 4 things and have only got one thing to work out. I used a little bit of intuition to get t equals 6 here, so we're going to avoid using that and just use the others, v, a and u. So, constant acceleration, v is equal to 0, a was equal to negative 2.5, u was equal to 15, and we're looking to find S. So we now go into our usual structure, state, sub, solve. So our state is the equation without t. Hopefully you recognise that now, or have learnt it. So you should be able to write down v squared equals u squared plus 2as. Sub in the values. Put in the value of u, 15 squared, plus 2 times negative 5 over 2 for the 2.5, just to make it easier to work with, s. Tidy this up. 0 equals 15 squared is 225. Positive times negative is negative. 5, the 2's will cancel, leaving 5s. So 5s equals 225. So S is 225 over 5, which is going to be 45 metres. Go back, read the question, check we've answered it. The total distance travelled during this time. Well, what was this time? The time between the instant when P first passes through O and when it returns. So the total distance is equal to 2 times the 45, which is 90 metres. Okay, homework attached with that. Will be, well, I've forgotten to check before I've done the example, so I'll just put up a tiny little clip like I did last time with the questions on. Okay, cheers.